pretty straightforward today, guys. I just want to talk about parallel lines and perpendicular lines on the coordinate plane. Um, Again, if you forgot what parallel and perpendicular mean, that's okay. We'll just talk about that real quick and then we'll get on with things, okay? So two parallel lines are two lines that are always the same distance apart from each other, okay? Um, they never intersect, right? That's the important characteristic of them, that they are parallel. Normally we denote off the coordinate plane that they are parallel with two symbols like that, okay? So these are two parallel lines even though they don't look like it, okay? So they're two lines that are always the same distance apart from each other, okay? I know we like to throw in that, they never intersect. That is true. Two parallel lines will never intersect. But remember, we can have parallel line segments and things like that. So if I had two parallel line segments, they might not intersect. So that's true for when they are lines, that they never intersect. But these two line segments don't intersect, right? AB and CD don't intersect, but they're definitely not parallel, okay? So again, if we measure the perpendicular distance, they're always the same distance apart from each other. And it is true, they never will intersect, okay? Perpendicular, different word. Perpendicular means that they make a right angle, right? So typically we would say something like this. But it doesn't have to be just left and right. It can be something like this. And before, what we did was we denoted that they were perpendicular with a little symbol that looked like that, like a little right angle box, right, to let you know these were 90 degrees, okay? And there were lots of properties and things that came out of perpendicular lines, okay? So real quick, that's what they are. On the coordinate plane, pretty straightforward, okay? If you are given a coordinate plane, I'm sorry about that. If you're given a coordinate plane, two lines are parallel, okay? So we'll talk about parallel first. They have the same slope. Okay, so let's take a look at an example of a line with a slope of 2/3. So say y is equal to 2/3 x plus 3, and y is equal to 2/3 x minus 5. Okay, these two lines have the same slope. We actually don't care about the y-intercept. I told you guys a little bit about that last week. We're not really all that concerned about it. We will be in the next few days. But say this one again. How do we graph? We start from 1, 2, 3. And what are we doing? We're going up to 1, 2, 3, up to 1, 2, 3, right? And we can just keep following this pattern, right? Down to 1, 2, 3, down to 1, 2, 3, to 1, 2, right? And we can go ahead and we can connect the dots, right? We can say that this is a line, this is y is equal to x plus 3. Now I do the same thing down from here at -5. So 1, 2, 3, 4, 5. Okay, and again, what do we got? 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Okay. So again, what do we get? We got a set of parallel lines. They don't look very parallel. Fix this other one up a little bit. They don't look very parallel, do they? But they are. Okay. These two lines are parallel. Be careful about the optical illusions of things. These appear that they are not parallel. They are parallel. If we count, again, let's pick a point. Let's say, hey, how far are these apart from each other? Let's go from this point straight down. 1, 2, 3, 4, 5, 6, 7, 8, right? So those are 2 points, 8. And from here, 1, 2, 3, 4, 5, 6, 7, 8. Now we should be measuring perpendicularly, but we don't know how to measure perpendicular distance yet, so we'll get there in a second. So be careful with the optical illusions. These don't look like they're parallel because of just the way the graph is laid out, but they are parallel. Okay, you can double check that way. Okay, so pretty much if two lines have the same slope, they're parallel. And just so you guys know, there can be, say like 3 lines. So what if I said y is equal to just 2/3 x, right? So again, where do we start from? The origin, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3, right? And we could just find kind of this way, right? We can have a third parallel line between them. So there is no limit. It doesn't have to be just 2. It can be 3 or 4 or 5, really however many you want there to be, okay? So anyway, anytime you have 2 parallel lines, they will have the same slope, okay? All right. Let's start a whole new one, okay? Perpendicular lines. Let's get a quarter plane out here. Oops. So we got perpendicular, sorry. Perpendicular. Okay, we're going to say they have the negative reciprocal slopes. Okay. 2 things have to happen. You need to flip the sign. Right, that's the negative part, right? Negatives will become positive, positives become negative. And second, flip the fraction. Okay, I don't want to get into the nuts and bolts of what the reciprocal is. You should know the reciprocal of 2/3 is 3/2, right? They multiply to make 1, okay? But for right now, 2 things, flip the sign, flip the fraction, okay? So if I said something like that, if I said y is equal to 1/2 x plus 5, right? So again, 1, 2, 3, 4, 5. Let's go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, right? You get something that looks, I don't know. Like this, okay? Now, if I want a line perpendicular to that, we don't care about the y-intercept. Okay, we'll make up a y-intercept as we go. What we really need to know is that the slope needs to be the sign flip. So this is a positive 1/2. Let's make it a negative. Okay, and we need to flip the fraction. 2 over 1 when we flip becomes 1 over 2 becomes 2 over 1, or just 2x plus 5. Okay, so again, we'll start from it's not start from plus 5 because I don't want to intersect there. I just want to show you it doesn't really matter where we started from. Let's start from, I don't know, 10 plus 10. Okay, so again, where are we going to start from? 10, and I'm going down to over 1, down to over 1, down to over 1. Okay, and you can just follow this pattern. Okay, the y-intercept, it really doesn't matter for these. Okay, because what's going to happen is all it's going to do is change where this line is located. Okay, so let's take this over to Desmos. Okay, so let's give you 2 lines that are parallel. Let's say y is equal to negative 3x plus 5, and let's say y is equal to negative 3x, I don't know, minus 7, right? Parallel lines, for sure, right? So again, their slopes have to be the same. The y-intercept is the only other thing that can change. Now, if I want a line perpendicular to this, okay, so we need to take our slope. We need 2 things. So negative 3 needs to become positive. So it was negative, now it's positive, okay? 3 as a fraction is 3 over 1, right? 3 as a fraction is 3 over 1. So our slope was negative 3, okay? So we need the negative reciprocal, okay? So what are we going to do? Well, let's start by saying this is really negative 3 over 1. Okay, let's make it positive, right? And let's flip the fraction, make it 1/3. So again, 2 things, flip the sign and flip the fraction, okay? So this will become positive 1/3 x, right? So there, right there, those are perpendicular lines, right? Now, by changing my y-intercept, all I'm really doing is changing where it's perpendicular, right? So all the y-intercept is going to do is change where it's perpendicular. If you give them the same y-intercept, all that means is that they will intersect at the y-intercept. Okay, that your perpendicular thing will be located there. I mean, that's about it, guys. Okay, so all you need to do is watch out for those slopes, and you can kind of take it from there. We will talk about how it will be more advanced. The next type of question will say, hey, it's perpendicular to this, and it goes through this point, right? And we'll talk about that, because then the y-intercept is going to matter. It won't be much more work just plugging in an x and a y and solving for b. But again, that should give you everything you guys should need for today. Hold on, no. I'll show you guys a few types of IXL problems, if I can get my mouse to work. Oh, give me 1 second. Okay, so let's look at a couple of problems you might see on IXL. It says a line A has a slope of -9/7. Line B is parallel. Well, we know when they're parallel, they have the same slope. So then it would also have a slope of -9/7. Okay. Line U has a slope of 5/7. Line V has a slope of 7/5. Are line U and V parallel or perpendicular? Well, neither. They are reciprocals, but the sign is still the same. This is positive, and this is positive. Right? So again, two things have to happen. Okay. Line T has a slope of -5/4. Line U is perpendicular to T. So what do we need to do? Let's make this is -5/4, so let's make it positive. And again, let's flip the fraction. 4/5. Okay. Line R has a slope of -3/8. Line S has a slope of 3/8. Are line R and S parallel or perpendicular? They are neither, right? So they flipped the sign, but they didn't flip the fraction. All right. The line of C is, the equation of line C is y is equal to -6/7x plus 9. Line D is perpendicular. What's the slope of line D? Again, flip the fraction, make it positive. Okay. I believe the only other type of question they might ask you is they might give you two sets of points. So a real quick example of that will be if they give you the points. I'll wrote a few down here. If they give you the points, 3, 8. Okay, so line A will go through 3, 8, and 8, 2, and 3, 12, and 9, 7. And I'll say, hey, are these parallel? Are they perpendicular? Or are they neither? So again, so what's the slope of A? Well, again, that's your change in Y over your change in X. Okay, well, your Y's, you went from 8 to 2, right? So that's a change of -6. Your X's went from 3 to 8. Well, that's a change of +5, right? They went up by 5, okay? Your slope of B, again, your change in Y over your change in X. Your Y's to what? Went down by 5. Okay, and this went up by 6. So these are neither, right? So your fractions are flipped, but they're both negative. Okay, so again, it's got to be that two-step process.